Just being aware. I think today was actually would be a good day to play some Christmas.
I know, yeah.
Christmas trivia.
It's a club day.
Well, we're gonna do some trig, yeah, trivia. Okay, so for the derivative, we got our y prime is 3 times the 8. We bring it down. So you get 24 times, you keep the same thing, like our smiley face, our emoji derivative, minus 1 times the derivative what's inside. So 6x squared. Is that what we got? I mean, you multiply and blah, blah, blah. Good? Okay. So
You want us to simplify every one that we do? Yeah.
I mean,
Like if it's simplify.
in homework, I'm not super worried about it. I would just make sure you're comfortable. Is my music playing?
2 girls, 1
No.
cup.
I would just make sure you're comfortable simplifying anything, because normally I'm going to ask you to get rid of fractional powers and negative exponents. Yeah. So just make sure you're comfortable. Like, I mean, if it's like a stupid multiplication, I'm not worried about it. I'm not super worried about it. And like, I think on my answer key, I multiply most of them out, but like, yeah. Now, when we get to the trig, there's certain things I want to know that you know how to do, like combining trig functions. So there'd be a little bit more simplification with the trig stuff, but something like I just did, I'm not super worried about it. Yeah. Good. Okay. All right. So everybody get your flashcards out, and I want you, well, actually, you know what? Actually, this is something you can do for homework today or after the lesson, because I don't know that it'll take us all period. You're going to put 2 examples from today's lesson on the notes. 1 raised to a power and 1 not raised to a power. And I'll show you what I mean. Okay, so you can get that derivative card handy. And so this is just a reminder of all the trig functions. Okay. So we're going to do chain rule of trig functions. There are kind of like multiple levels of this. So turn to your worksheet, your note sheet. Level 4. Well, you're going to add stuff to it at the end. So, and I'll tell you maybe one thing you want to add. So this one right here. Okay. So guess what? You guys actually already know how to use the basic chain rule for trig. And let me show you. Remember y equals tangent of 2x. How do we derive that? Derivative is, yep, secant squared. So it's secant squared of u prime. And I just told you before, we can just ignore that and just take the derivative of what's inside. I kind of like, I didn't tell you it was chain rule. Now I'm telling you, we were doing chain rule. And I didn't ask you too often, but I wanted to kind of like ease it in. So we have y prime, or let's do dy over dx. dy over dx is the secant squared of 2x times u prime. So you understand this guy, 2x is u. My laptop's in the way. So I'm trying to record it for Zoom. So is there a way that you could you maybe move to that? Oh, so sorry. Until they fix my my technology is not working like it was, because when I would type on or when I would write on this, it would immediately come up, and now it's not. So I have to like, is that good? Okay. All right, times 2. And this would be, 2 secant squared of 2x. Is that good?
Yep.
Okay. Number 2. dy over dx is okay, so what is u here? Do you know what u is? 5x squared. because do you understand? This is, sometimes they put parentheses, sometimes they don't. So it's whatever's kind of connected to it is that's your angle, okay? So I'm gonna do 4 cosine of 5x squared. That stays the same, right? Because the derivative of sine is cosine u prime. So we do cosine of u times your constant. U prime is going to be 10x. So this would simplify to, 40x. We usually put those in front of the trig function times the cosine of 5x squared. So that's dy over dx. Okay, good. All right, this next one, what is u? U is 3x squared minus 2x. So the derivative of cosine, let's call this one y prime, is, do you remember derivative of cosine u? Yeah, negative sine u prime. So we're going to do the negative sine of, this is u, 3x squared minus 2x times u prime. 6x minus 2 is correct. Good. Okay. And you could put that in front, whatever. I'm fine with that. Okay. I'm just reminding you of this. The next thing that I'm going to have you do is we can derive functions that have exponents. Do you remember these? Tangent squared of x means tangent x times tangent x, right? So we can write that one of two ways, like this. The square is in front of the x, or I can also write it like this. The key here is to rewrite it. Yeah? Because now do you see that the chain rule says I can take anything to a power and derive it, right? So now it looks more like the chain rule. Does that make sense? So always rewrite it. Always rewrite your trig functions if they have a higher power. So then what does the chain rule tell me to do? Now, bring this in front. Here's the weird stuff. So f prime is going to be bring the power in front. You get same, right? Keep the trig function the same. It becomes 1 less, so it's to the first times derivative of what's inside, u prime. So we got, what's the derivative of tangent x? Secant squared x. Now that's like a basic one, okay? So you could write that as 2 tangent x secant squared. Okay, that would be like your final answer. Does that make sense? Okay, let's do another one. I'm gonna let you try this one. Try number 5. Take a second. Rewrite it. Bring your power in front. Keep it the same. Reduce the power by 1. What's the derivative of secant x? Secant tangent, right? Secant x, tangent x. You can see on your derivative card if you need it, right? Now, can I simplify this in any way? Yeah, what power would it be for secant then? Secant cubed, right? We add our powers. So this would be 6 times the secant cubed of x tangent x. Is everybody good with that simplification? Just making sure we're good. It's been a while since we simplified weird function stuff. Okay, and the next one is weird. Okay, how would I rewrite this one?
Ooh, 12 cos x to the 1/2.
12 times the quantity cosine x to the 1/2. Okay, so f prime is 1/2 times 12 is 6. Yeah. Times, what do I do? Cosine X stays the same,
Negative one.
-1/2, there we go. And then anything else? So, yeah, derivative of cosine is, careful, negative sign. Oops, sorry, cosine of X. Okay. To deal with that -1/2, do you know what to do? Negative powers go to the denominator to become positive. So I would say this is -6 times the sine of X divided by, it would be like cosine X to the 1/2, right? Which you could say is, I probably wouldn't write that step. I would just go right to here. Because I know that it translates to that, whatever you're comfortable with. That makes sense? Okay. All right. Are you ready to kick it up a notch? Okay, here we go. Chain rule within the chain rule. So notice the problems I gave you that we just did was like, I stuck to cosine X, tangent X, right? But look at what I'm doing here. You have, it's raised to a power and it has a quantity. So first let's rewrite it. It becomes the cosine of 2x raised, or it's squared, right? Raised to the second power. Now, the chain rule says, let's do our dy dx. The derivative is, bring your power in front. Does that quantity stay the same? Cosine 2x?
No, just to divide.
Everybody say yes.
Yeah.
Yes, right? It stays the same. Remember my happy face math, right? So cosine of 2x, reduce the power, right? The only thing that changes in that quantity the first time is its power, right? Then I need to take the derivative of what's inside, which is negative sine 2x. Okay, but you're missing something. Because what's the derivative of cosine of u? Yeah, negative sine u prime, right? Is there a u prime? Yeah, it is. So this is like the u, right? So I have to derive again. That's my u prime. So times 2. Does that make sense? I'm looking at it. It's a little weird, right? I warned you. I said it's a little weird. So recapping, we go, okay, this is my main. My first chain in a trig function is its power. That's my first chain. So this is like my first chain. Okay, I do that. I bring the power in front. I subtract them from the power. And then my second chain is because when I have a trig function of something other than x, that's going to be a double chain rule. Okay, this is a double chain. So I'm going to say the derivative of cosine 2x is negative sine u prime. So negative sine 2x times 2. Yeah. And cleaning it up, you'd get, let's just clean this up. It would be -4 cosine 2x sine 2x. Okay. Because this, and this. Right? That negative in front of the sign times the 2. It's all multiplied together. So I could write this as -2 times 2. Yeah. Multiplication is commutative. You can move that around. Okay. You guys want to try one? Try number 8. Try number 8. It's a little tougher, isn't it? You have to really think about these. Try number 8. I'll come around to answer questions. If you had a question about what I just did, feel free to ask now.
And becomes.
Yes.
Yeah.
So what I would do if I were you, I would write on my derivative card. I told you to write 2 examples tonight. I would write one of these with the power. And then one of the other ones we did without a power, like. One of the very first three that we did, I put one of those on, and then I put one of these on my derivative card. Are you guys ready? So rewrite, it's going to be the tangent of 5x cubed. What helps me is I also put parentheses. Sometimes they won't put parentheses, but what helps me is to remind myself, I'm gonna have a double chain because I have a power and something other than x in my angle, all right? So I'm gonna say y prime will be power in front, keep it the same, right? Reduce the power by 1 to 2. Times the derivative of what's inside. So the derivative of tangent u is what? Secant squared u prime. So do you understand this is like now my second u, my second chain? So I'm going to say my derivative of what's inside is secant squared of 5x times 5. We getting it? Is it?
To the second, does that need to go with this again as well? Like, it's tan 5x to the second, is this?
Oh, that's a great question. I know exactly what you're thinking. No, because that the secant squared happens to just be the derivative of tangent. Does that make sense? Yeah. Okay, so then this would, your final answer here would be 15 tangent squared of 5x secant squared of 5x. Yeah?
Could you do like tan squared then 5x, or does it have to be the weight?
Could you do tan squared? You mean secant squared first?
No, tan squared and then 5x.
Ta-
Or is that like?
I think that's what I have, right? Yeah? Teach
Shoot,
tan.
no, I got tan 5x squared.
Okay, well, okay. Oh, I'm glad you asked. Did you write it like this?
No, I put parentheses around.
Good. Okay, because that would be wrong. But if you did this, that would still be fine. Yeah. Typically, when we fully simplify trig functions, we write it because it's nicer for trig, right? It's nicer for trig when you're looking at tangent squared of this. It's nicer for calculus when you're deriving or integrating later on to use that notation. Okay. Yeah. Now, if you did that on the test and your final answer, I wouldn't take off points. But if you wrote it like that, that would be wrong. Okay. So that would be fine. All right. Let's do another one. So this is kind of tricky. I'm kind of being, well, okay. Well, not tricky. I mean, you might be asked something like this. And here's why I say that I would prefer to use algebra to make the calculus easy rather than do complicated calculus. Okay? So let me ask you a question. What algebra could I do here to make the calculus a little easier? Yes.
Simplify 3x squared.
I can simplify 3x squared. Do you see it?
Sure.
What's 3x squared simplified to? 3x squared means 3x times 3x. You square each one is 9x. Yeah, I would absolutely 100% simplify that. And I'm going to show you both ways just so you know why I would do that. Because the other way is yucky. All right. So my first step would be, now notice the trig function isn't squared. It's that angle that's squared. Yeah. So this is the cosecant of 9x squared. I would write it like that. Okay. Then I would do my derivative. So I would say y prime is cosecant. What's the derivative of cosecant? Cosecant u. It's going to be, is it cosecant cotangent, right? Yeah. Cosecant u cotangent u times u prime. So I'm gonna do cosecant. Now this is only gonna be a single chain because the trig function isn't raised to a power. Do you understand? It's only one chain. So it's going to be the cosecant of u, cotangent u, right? So u is 9x squared. That might help you to write. Times u prime. The derivative of u prime is 18x, right? So it's all times 18x. Okay. So, oh, I'm sorry. I missed something. The derivative of cosecant, what does your formula sheet say?
Negative.
Negative. Put that negative in there. Sorry about that. Okay. So it'd be negative. My final answer would be like negative 18x cosecant 9x squared cotangent 9x squared. Now, can I show you what the other way looks like? It's gross. If you miss that you can use algebra to simplify this, here's what you'd have to do. You would do, I'll do this in this way. So this would be cosecant of 3x squared. So what you would do is y prime is the derivative of this. So it's negative, whoops, sorry. So u would be 3x squared. Do you see that this would be right here? This actually requires chain rule. In taking the derivative of u, that requires the chain rule, right? So if I were to take du, it'd be 2 times 3x times 3, right? Or u prime. I've been saying du and u prime are the same. So if I would derive this, I would say negative cosecant u, cotangent u, and then u prime. This is all u prime. So the derivative of that 3x quantity squared would be 2 times 3x to the first times 3x. Isn't that gross? I wouldn't want to do that. If I can avoid it easily, I avoid doing a double chain. Sometimes you can't avoid it, but when you can, I do. Okay. So right now, you guys have some practice problems. There's more to the trig function lesson, but I figured I'd save that for tomorrow. Am I right in doing that?
Yeah.
Yeah? I don't know that we want any more
agree.
new stuff today. Okay, good. I was thinking with how you guys did really well with the stuff yesterday. I was like, oh, maybe I should throw it in, but I knew this was coming. So. Okay, right now, go ahead and do those. I think there's just 10 problems, right? So work on those. That's it. That's all. That's your assignment today.
Not like half solid grade, so like.